Okay, now in this lecture we are going to focus on the term called as what physical design of IoT. So whenever you are planning for any IoT project, that project will be divided into the two parts: the physical things that you can see through your eyes, and second is the architectural part that we cannot see but that should be there. So we are calling it as what logical design of IoT. So the first we will focus on physical design, and then next we will focus on logical design. So what is meaning of the physical design of IoT? So I will just show you one simple diagram. Okay, so just focus on this diagram. It is known as generic block diagram of an IoT devices. So here, if you could able to find out, we have a different parts like here, IO interface, audio, video, processor, connectivity, memory interface, graphics, and storage interfaces. So the things in IoT, which usually refers to the IoT devices which have unique identities and can perform remote sensing, actuating, and monitoring capabilities. So IoT devices can exchange data with other connected devices and applications directly or maybe indirectly, which can collect the data from other devices and process the data locally or maybe from remotely, send the data to centralized server or cloud based applications like backends for processing purpose, perform some tasks locally and other tasks within the IoT infrastructure based on temporal and space constraints. So basically what we can say, the things which we are trying to connect on internet, the things should able to have interface, means input output interfaces, should able to collect the audio video, it's kind maybe image, maybe sound, should have their own processing unit at their local side or maybe directly to a remote side. So we need a storage interface, should able to take the decisions at the local side. So for that we need some processors, we need some connectivity part there, and also we need some memory interfaces. So these are the generic block diagram called as one physical design of IoT system. So let's focus on the first part called as what IO interface, that is input output interface for sensor and actuators. So that entire sensors and actuators will be connected through this IO interface. In that the first part is capital UART, which stands for basically Universal Asynchronous Receiver and Transmitter. Second is SPI. It is known as Serial Peripheral Interface. Next is I2C. It is known as Inter-Integrated Circuit. Next is CAN, which is known as Control Area Network Interface. These are the ways through which you can able to connect to an internet. Basically your sensors and actuators, these all connected to this interface. These are the different types of IO interfaces in IoT devices. Next, coming back to the next part, you may able to see audio video interface, that is HDMI, high definition, high definition multimedia interface, then audio jack similar to the mobile 3.5 audio jack, then RCA, that RCA stands for Radio Corporation of India, that can be used for that input audio video interactions. Next is storage information, that is SD, which is known as secure digital, MMC, which is known as multimedia card, normally we says memory card. These are the different types of media cards, multimedia cards. Then we have DDR, that is double data rate type of RAM, basically we are using. So this is just remember. So any devices like your mobile phone have charger, input output interface, audio video is also there, processor memory is there, graphics, Then for the connectivity, you may connect with USB, or you may connect with internet directly through Wi-Fi, or enabling internet connection on your devices. Memory interfaces, your device may have local storage, or you may go for an expansion of memory card. These are the some common examples for physical design of IoT. Now once you are clear with this, we need to think about the different protocols that may exist over there. So that protocol part we are discussing as IoT protocol. So simply remember one diagram. One more diagram is there. It is divided into the different layers, like first is link layer, second is network layer, and third is application layer. So we need to understand these layers: link layer, network layer, and normally that link layer is known as data link layer. So data link layer, network layer, transport layer, and application layer. Now let's see each layer. Let's, if we see here, so in case of link layer, we have a different protocols over there, not limited to this. A continuous evolution is going to there. So Ethernet, Wi-Fi, WiMAX, then this LRWPAN, low rate wireless personal area network, then second generation, third generation, long term evolution, that is 4G, now 6G, 7G, like that, cellular parts. This all comes as a part of your link layer. Next protocol, IoT. As far as network layer is considered, we have an options like Internet Protocol version 4, version 6, then 6 low power wireless person area network. In case of transport layer, we have TCP, that is Transmission Control Protocol. Wired connections, basically we connection oriented, not wired, sorry, it is connection oriented. And in case of UDP, it is connection less, user datagram protocol. In case of application layer, we have protocols over there like HTTP, that is Hypertext Transfer Protocol, Constrained Application Protocol, WebSocket Protocol, then MQTT, XMPP, DDS, and AMQP. These are the some common examples that we can able to see as a part of protocols in application layers. So for each layer, we have a different protocols. So let's focus on the each one of them. So link layer IoT protocols, these protocols determines the basic purpose of link layer. Data link layer is to connect, determine how the data is physically sent over the network, physical layer or medium. So the scope of this link layer is local to network connection to which host is attached. Host on the same link exchange data packets over the link using data link protocols. So link layer determine how the packets are coded and signalized by hardware devices over the medium to which the host is attached. So the first protocol we can see here is 802.3 Ethernet. It is wired Ethernet standard. 802.3 is a standard for 10 base 5 Ethernet that uses coaxial cable for the sharing purpose. 802.3i is a standard for 10 base T. Earlier was 10 base 5. This is 10 base T Ethernet over copper twisted pair connections. So earlier for the first was coaxial cable, then next is copper twisted pair connection. Then 802.3j small j is the standard for 10 base F Ethernet over fiber optic connections. So what type of a connection you have, based on that in data link layer your protocol of Ethernet will begin used. So in case of fiber connections, we may use for 802.3 AE, which stands for 10 Gbps Ethernets, and the data sending capacity range called as what data rates may be ranging from 10 Mbps to some applications 40 Gbps, 40 Gbps in case of 802.3. Next we have 802.3 Wi-Fi parts is what we can see. So that is 802.11. In case of that, Wi-Fi option is there. So it is wireless local area network communication standards, including extensive description of link layers. So here data rate is ranging from 1 Mbps to 6.75 Gbps range we can able to get over there. So 802.16 WiMAX, this is collection of wireless broadband standards including extensive descriptions of link layer and the data rates that we can achieve in 802.16 WiMAX wireless is 1.5 Mbps to 1 Gbps. The latest technology what we can say is kind of an WiMAX. So if we see the difference between Wi-Fi and WiMAX, so major difference is what we can say. Wi-Fi connection can transmit up to 54 Mbps, where WiMAX can transmit up to 70 Mbps. Wi-Fi has a very limited range, around 100 meters. WiMAX has a range of 50 to 90 kilometers. Wi-Fi does not guarantee any quality of service, where WiMAX guarantee quality of server. So simply we can say Wi-Fi is for the LAN, that is local area network, where WiMAX is for metropolitan area network, that is what MAN. So understand the main difference between Wi-Fi and WiMAX. Then we have this 802.15.4 LRWPAN, which is collection of low rate wireless personal area network. The standards provides low cost, low speed communication for powered constrained devices, as the name suggests. Low rate, so maximum data rate that we can achieve here is 40 kbps to 250 kbps per second. Now next is what we can say 2G, 3G, LTE cellular. So the difference generation, these are known as different generations of mobile communication standard. So second generation, that is known as 2G, which is known as GSM, known for Global System for Mobile Communication, which is using GSM technology. Then there is a evolution, one more technology is there called as what CDMA, which stands for Code Division Multiple Access. There was some limitations that earlier we could able to send only text message. Then next technology came, which is a combination of text plus some other media, like maybe audio, maybe video, or maybe image. So we call it as what 3G, which is known as Universal Mobile Telecommunication System, that is UMTS. 3G generation is their third generation, which are using in 2G we are using GSM, in 3G we are using UMTS. Earlier there was the CDMA, now we are using CDMA 2000s, and then recently we can that all are started to use the 4G technology, which is long-term evolution, that can be able to send a combination known as simply multimedia, no only calling, along with the calling you can have a video call, audio call. So this is what the some common examples to understand the 2G and 4G. The highest thing is what we could able to get here is data rates, which are starting from 9.6 kbps to 100 mbps. So this is what your link layer called as what data link layer. Now next layer we have is network layer. As the name suggests, network layer is basically useful for connecting host to host. So host to host connections we could able to get over there. Unique identification can be done with the help of a protocol called as what internet protocol, and based on the internet protocol we can have a different versions over there, named as IP version 4, that is internet protocol version 4, internet protocol version 6. You already aware about this difference between version 4 and version 6. So we will focus directly on the 6 LOWPAN, which is known as low power wireless area network. So 6 low power wireless personal area network is nothing but IPv6 wireless personal area network, which is using IP version 6. So it is known as 6 low power wireless personal area network. operates in 2.4 gigahertz frequency. Basically the data rate, as the name suggests, low power, so it is max of 250 kbps. Next is in case of transport layer. What is the basic purpose of transport layer? It is process to process communication. Network layer, host to host communication. In case of transport layer, we have two options, whether the process to process connected by connection oriented or connection less. Accordingly, that we have two protocols over there. One is TCP, second is UDP. That you already aware about that, so I will not take much of time over there. Then the next type of next layer in IoT protocol is application layer. In case of that application layer, we have a different protocols like HTTP, which stands for Hypertext Transfer Protocol, which forms the foundation of World Wide Web, includes commands such as get, put, post, delete, head, trace options, which follows the request response model. So normally request means client request will be done, based on that request server will provide the response, so it follows the request response model. Second is CoAP, which known as Constraint Application Protocol. Simply remember, in CoAP O should be small. So that CoAP stands for Constraint Application Protocol. As the name suggests, constraint means some limitations. So basically it is used for machine to machine applications, that is M2M. It is meant for constrained environments with constrained devices and constrained networks. It is a web transfer protocol like HTTP, which uses a request response model. And most important part, CoAP protocol can run on top of UDP instead of TCP. In case of wireless communication, mostly we will prefer to use CoAP. Next is a WebSocket. As the name suggests, WebSocket is nothing but kind of an interface, kind of plug and play architecture. So connections will be possible in case of HTTP connections like that. Next is XMPP, which is known as extensible messaging and presence protocol, which is a set of open technology for instant messaging, presence, multi-party chat, voice and video calls, collaborations, lightweight middleware, content syndications, and generalized routing of XML data. So XMPP was originally developed in the Jabber open source community, and purpose was to have open decentralized alternative to closed instant messaging services. So XMPP offers various advantages like open, standard, proven, and decentralized, and most important part, it is a secure protocol. So XMPP stands for Extensible Messaging and Presence Protocol, and it is used basically for real-time communication and streaming XML data between network entities. Next is DDS, which is known as Data Distribution Services, and the basic purpose of this DDS is data-centric middleware standards for device-to-device or machine-to-machine communication. And next is AMQP. As the name suggests, it is Advanced Message Queuing Protocol. So this AMQP stands for Advanced Message Queuing Protocol. It is open application protocol for business messaging. It supports point-to-point publisher-subscriber model. In upcoming slides, we will discuss what is publisher-subscriber model. Also, it is supporting routing and queuing technology. So this is IoT protocol. So what we have covered? We have covered physical design of IoT. In physical design of IoT, we have seen, if you will remember, we have seen one important diagram over there in case of physical design known as generic block diagrams, and then we have discussed what are the different protocols available in the IoT. So what are the different protocols available in the IoT? We have to understand with respect to the links, So link layer, network layer, transport layer and application layer. In link layer different protocol, network layer different protocol, transport layer different protocol, application layer different protocol. So this is what the physical design of IoT. In next lecture we will focus on logical design of IoT. Any doubt so far?